Okay, so here's what we have left between today, tomorrow, and Friday. So today we've got a lab, because especially with this electrolysis, it's kind of important that you see how this actually looks. So there's a couple of options that you can use for your universal indicator. But the short version of what you're going to do is that over here on page 2, you're going to be mixing up, I've already mixed up 3 solutions. Silver nitrate, sodium iodide, and sodium fluoride. Labeled, boom, there you go. So here's what's going to be most important, and I'm going to force you to do this. So the first thing that you want to do is write down what's in the solution. So if you have silver nitrate, what are the 3 things in that solution?
Silver, nitrate,
Silver,
full nitrate,
not silver,
silver ions,
you have silver ions,
nitrate,
you have nitrate ions, and you have
water,
So what that means
water.
is that the only 3 potential reactants you can have are silver ions, nitrate ions, and water. Okay? That's it. You cannot have oxygen, you cannot have silver, you cannot have hydrogen, you cannot have H pluses. The only thing on that first one you can have as potential reactants are silver ions, nitrate ions, and water. Now, you're going to have a little weighing dish. You should have them in your drawer. If you need one, let me know. You're going to take a 9-volt battery like this, and you're going to hook up leads to the positive and negative terminals of the battery. Then you're going to take a piece of graphite, okay, and I'm going to have like a container like this, just shake some out, and one like this. So, because of the fact that we're doing this in such small scale, all it takes is like 3 or 4 drops. So here's going to be your weighing dish, and you might even like tilt your weighing dish so that all the liquid stays on one side so it isn't all spread out. So you're going to have that solution in this corner. Run this a couple of times. What you might do the first time is not even put an indicator in it, okay? Just see what happens, because if you're forming iodine or you're forming silver or some of these elements, if you have an indicator in it, then that indicator will like sometimes mask the color of what's happening. So you just might even try it just straight up. Now, there's a couple of options you can use for your indicators. The new one is what we call bromothol blue. I don't have a whole lot of this. I have no idea what happened. We used to have bottles of it. This is all the bromothol blue I can find. But the cool part about bromothol blue, as the name, opposite of the name. I was going to say oxymoron, but that didn't fit. The opposite of the name is that bromothol blue turns yellow in an acidic environment. So, and that's just it. It's a one-trick pony. Okay, just like phenolphthalein only turns in a basic. So bromothol blue is kind of the opposite of phenolphthalein. If you want, you can use a universal indicator because that covers the entire spectrum of acid to base. I don't care which one that you do. So one of the key things I'm going to look for. First off, you've got these pre-lab questions to answer. You don't technically need to do them as the pre-lab, but it might be beneficial. So over here, you're going to make observations about what happens at the anode, what happens at the cathode. And I don't care how you play this out, but certainly if you look at this and you have Ag+, do you think Ag+ is going to get reduced?
Wait, yes, reductions gain. Oil rig. I had to think. The way you phrased it made it sound like you were supposed to say no.
I don't have it. You do have a certain tone of voice for things like that.
Okay.
I'm not doing it.
I'll try and do that neutral.
Okay.
Do you think Ag+ is likely to be reduced into elemental silver?
Yeah.
Yes.
Yes. Why?
Because it wants
Where's
to-
it at on the reduction chart?
High.
It's up above.
Yes.
You have nitrates. Is Mother Nature gonna touch the nitrate? No, nitrate's a lot, okay? It's complex, it's emotional, it's negative, it's got 3
She's just like me
oxygens.
for real.
Mother Nature goes, you're emo, I'm not touching you. So, you know nitrate is not gonna be part of the story. So you know water is gonna be reduced, excuse me, so you know silver is going to be reduced, so that means water to be.
Oxidized.
So here's what you wanna keep track of. What happens in the reduction of water, what happens in the oxidation of water. They're both on your sheet. One of them is written as a reduction. The other one you have to reverse, okay? One produces hydronium ions, one produces hydroxide ions. One produces hydrogen, one produces oxygen, okay? So that's a cool thing to just test that. Okay, right. If you know which one is which, and you know which one is producing hydroxide ions, drop a little phenolphthalein in there and see what happens. It's a simple test. Okay, so on this chart, and let's just make sure everybody's cool with this. The silver plus is going, on this first one with the silver nitrate, the Ag plus is going to get what? Reduced. Into the elemental silver. Is that the cathode or the anode? Cathode, right? Red cat. Red cat on 3, break. Ready, hit. So, right away, that can tell you, and I've got different color wires on your tables. So your first one will tell you, hey, hook this up, see which one is producing the elemental substance. Then you know which of the 2 wires is your cathode, because that's the one that made the elemental silver. So establish that as a baseline. In my situation, is it the red one? Is it the yellow one? Hook it up, put it in the solution, see what happens, okay? Then you're gonna do the sodium iodide, and the last one you're gonna do is sodium fluoride, okay? Write down what's happening at each one. Now, let me explain how I want you to answer these questions. On 1A, it says, what product was formed of the anode in the electrolysis of the silver nitrate solution? Explain citing specific evidence from your observations. So just don't tell me, oh, it was oxygen. How do you know? Okay, if you produce oxygen, let's say, how do you know it was producing oxygen? What else is going to go with the production of oxygen? What else is going to go with the production of hydrogen? If you're producing elemental bromine, what does that look like? If you're producing elemental silver, what is that going to look like? So just don't say, oh, it made silver. How do you know? Or if it made oxygen, how do you know it made oxygen? Because if you make oxygen or hydrogen, there's something very specific that is produced that you can test with indicators. Okay? Just saying. So, when you get to question 3, okay? Or 1, 2, and 3, they're all the same. Tell me what's happening at the anode, tell me what's happening at the cathode. When you get to number 4 for each of the 3 cells, right, the overall balanced net ionic reaction. They're balanced. It's a net ionic. So Gap Sean, what do you need? Huh? And charges? Okay? Do not, on number 4, write down anything as a reactant that is not in the solution. Is hydrogen gas a potential reactant?
No.
No. I'm not giving any of you bottles of hydrogen gas.
Dang it.
Okay? Sorry. Just saying. When you get to Number 5, and I'm asking you about turning yellow during the electrolysis of silver nitrate. That's specifically assuming that you have added bromothol blue to the solution, okay? That's specifically what I'm asking about that. On the sodium fluoride, and this is more of a theoretical question. Question number 7, you got to go old school acid-base ideas before you answer number 7, okay? Old school, weak acid, strong conjugate base before you answer question number 7. When you get to question number 8, this is this big stoic problem, okay? It's 2.5 amps. We're going to run it for 2 minutes. What's the mass of the silver produced? When you get to 9, you're going to calculate E naught, delta G, and K for the electrolysis of silver nitrate. Before you do any calculations, what should be the sign of your E naught value?
Negative.
Why?
It's not spontaneous.
What do you have to do?
Charge it.
You got to have a battery source. So your E naught should be your G value should be, and your K value should be small. Okay. Now, on number 10, I'm going to take a piece of copper and I'm going to drop it into a solution of silver nitrate. On number 10, is a battery involved?
No.
No. No. Why? Why do I not say you need a battery? It's a spontaneous reaction. Okay? When you answer number 12, you're given a beaker of water and phenolphthalein indicator of battery leads in graphite. Explain how you can determine which is the anode and which is the cathode based upon observations. Be specific. You're going to say, this is what's happening at the anode. This is what's happening at the cathode. This is what's being produced. Keep in mind, you only have phenolphthalein. You don't have universal indicator. You don't have bromothol blue. You have phenolphthalein, the leads. Okay? Look at what's going to happen to the amount of bubbles. Which one's going to produce more bubbles, the anode or the cathode? Okay? Just saying. Okay, I am done. You don't have to do this in order. You don't have to go in that sequence, but here we go.